Yeah. Why is it that every time I hit somebody, it's shot full screen sharing?
Oh God, no, but you can just have it set up not to, or you have to, you ask Ilaria to be in and. You have to set it up so that the room doesn't.
Correct. Okay, good.
This is good now? If people.
Okay. Cool.
Okay, hello everyone. For the GeoMIP participants, thank you for sticking around during the long day. I'm glad you're still here with us. There will be a reward in the form of barbecue after this talk, so thank you for sticking around. For everyone else, the rest of the Cornell community that is here, welcome. This is a public event that is part of our GeoMIP meeting. This is the 14th GeoMIP meeting. GeoMIP stands for Geoengineering Modeling and Comparison Project. We're a group of scientists that, starting in 2009, started to convene to standardize experiments, climate model experiments around the topic of geoengineering or solar radiation modification. And we co-chaired together with Alan, and I have been for the last 4 years, but the GeoMIP was funded by Alan and Ben, who's also in the room. So yeah, this is our 14th one, our 15th one. The next one is going to be in South Africa. So it's going to be the first one on the African continent, and we're incredibly excited about it. But today we really wanted to have this public event in the university where Carl Sagan also used to teach. There's absolutely no correlation between Carl Sagan teaching and me teaching here, but you know, this is the standard that we're going down with. But anyway, so we wanted to have this public talk because of all Oliver has done for this field, and because Oliver is a great friend of GeoMIP, so I'm super happy to have him here, and thank you, Oliver, for accepting.
Thank you, Daniel. Yep. Anything to that? I'll just let Oliver take it away.
Well, thanks very much and good evening. And it's a great honor to have been asked to give this public lecture in conjunction with GeoMIP. For the members of the public who don't know, GeoMIP is a sodality of climate modelers researching issues around solar geoengineering, which is the cooling of the climate or the slowing of its warming by means of reducing the amount of sunlight absorbed at the planet's surface. They address those issues with a mixture of urgency and caution, fascination and concern. They treat a topic which might be seen to reek of hubris with a real humility. In what seems to me like a mark of the perversity of the world, that may well be one of the reasons why the implications of what they're doing is nothing like as widely appreciated as it should be. So, you are unsung heroes, well done. Given what GeoMIP works on, and given the location of the meeting, and given, well, me, there was really only ever going to be one focus for this talk, which was Carl Sagan, who was a professor at Cornell for most of his career. Does that work? No, that doesn't work. Does that work? Okay, no, that's okay. I have to advance it with a different thing. There we are. There we are. Carl Sagan, talking in a classroom not that far from here, I suspect. Sagan, who I will probably end up calling Carl and Sagan randomly throughout the rest of this talk, was a pioneering planetary scientist, a peerless popularizer, a leading public intellectual, and on some issues, a political activist. He was also the person who committed to print the term planetary engineering to cover the deliberate changing of a planet's climate. For example, through changes to its albedo, the amount of sunlight it bounces back into the universe, or to the chemistry or indeed physical bulk of its atmosphere. In Sagan's conception, which I think was a good one, planetary engineering encompasses geoengineering on the Earth, terraforming in the sense of making more Earth-like on planets like Mars and Venus, and also what has sometimes been called ecopoiesis, engineering aimed at making a planet more habitable, but not necessarily more Earth-like. And so I want to look at the relationship in Sagan's work and that of others between the ideas about about the engineering of other planets and about the improvement of this one, or at least the slowing deterioration of this one, perhaps. But I'm also going to try and go a little deeper. The underlying theme of my work as an author, expressed to some extent in more or less all of my books, is an attempt to understand and articulate the relationship and distinction between the concept of world and planet. It can to some extent be seen as that of the subjective and the objective. Worlds are seen from within. They are experienced as social and physical environments. They are multiple and kaleidoscopic. They are belonged to. Planets are seen from outside, investigated as physical phenomena, unitary, measurable, immune to lived experience. In his lyricism, with which he was well supplied, Carl Sagan, for the most part, uses the terms almost indistinguishably. But ever since being challenged on the matter by my wife, the poet N.J. Hines, when working on my first book, I have tried not to. I've tried to keep the tension between world and planet very much at the center of what I do. And it's been endlessly enriching to find myself caught up in the ideas like yin and yang, the degree to which they cannot be reconciled and the degree to which they have to be reconciled. By feeding the imagination, something I try to get across in the title of my first book, I put up there just to show you that there's lots of Sagan in the index, it's probably true of the other ones as well. The paradox, which is intellectually appealing and aesthetically rewarding for me, has also proved in terms of geoengineering, kind of intractable. The science of geoengineering imagines the Earth to be a planet represented in and to some extent as a machine. But the politics of geoengineering remain the politics of the world. There's not yet a way of talking and doing politics at the planetary level. And it may be that there are good reasons for that. Such politics might be unsavory. But without them, the idea of actively working for a better planet rather than a better world is hard to grapple with. So this is the quotation that I thought of when Daniele suggested this talk. And it's from a review paper on planetary engineering published in '93 by Sagan and his collaborator, Jim Pollack. More work is needed, but comparatively inexpensive and environmentally prudent methods of mitigating greenhouse warming on Earth may be within reach in the next few decades. It's a clear statement from a position of scientific authority about the practical possibility of geoengineering. As such, I think it's something the world could do with more of. It is also true. True then, truer now. Note that mitigation is not in the technical climate change sense there. It's not about emissions reduction. But then, one of the most famous scientists and public intellectuals in the world could put his name to such a forthright statement quite happily. Today, no one would do so with so little in the way of caveats. And that's partly because there is no one like Carl Sagan anymore. There's no one with remotely the public profile that Sagan had in the 1970s and 1980s. No natural scientist. If anyone can think of an exception, I'd be delighted to hear it afterwards. But it goes deeper than that. When Sagan said it, nobody noticed, and Sagan did not go out of his way to have people notice. Google Scholar, that reputable source, tells me that I'm one of only 2 people ever to quote this quote in the context of geoengineering. It's all normally quoted in the context of doing very strange things to Mars. This may be in part because Sagan did not want the FSU noticed in discussions about climate science. There were some issues there. It was a statement made by planetary scientists and for planetary scientists. You only have to see where it was published to understand that. Resources of near-Earth space. Most of the papers are about in situ resources for the use in outposts on the Moon and Mars, or asteroid mining, and some technologies for the deflection of asteroids. And there's another long story about Carl on that subject, which I'm not going to go into. Why this paper ended up there too is something of a mystery. Perhaps planets themselves are resources. I'm not implying something as crass as thinking they are just resources, but this is very much a context of objective realities and objective functions about what might be done if some disembodied will were applied to the planet in question. It's a planet statement. It's not a worldly statement. Within reach. Whose reach? And if it is reached, what then? The statement's implicit assumption, that of the article as a whole, is that it would be within the reach of some sort of planetary supervisor who would make rational decisions on the best evidence with clearly stated ethical and environmental boundaries. It's not the sort of assumption one can make when thinking about geoengineering. Put more succinctly, geoengineering is planetary engineering plus politics, and the qualitatively different nature of the items on either side of that addition make that a very hard identity to act on. And this is not to knock Sagan. It's an attempt to tease out, as the rest of these remarks will be, some distinctions in the history of a set of fascinating and now important ideas. The fact that some of what I have to say can be read as a counter to Sagan is to some extent a reflection of how deep his influence on me has actually been. When I was writing this and finding all the things I wanted to say, which I won't, the topics I returned to, I found that the topics I returned to again and again, the imagining of other worlds, the co-evolution of life and Earth, the future of humans beyond the Earth, what it might be to communicate science, how we talk about wonder. These are all topics where he made huge contributions, mostly huge anyway, and to which he exposed my young mind. As a token of the interlinking, see if you can see any similarities between the cover of Resources of Near-Earth Space and the cover of The Economist's 150th anniversary issue, published the same year. Yep, same illustration, same artist, partly because of a very few people who paint asteroids, but there you go. Anyway, enough of my yakking, as Marty de Burghi so famously said. Let's boogie. I read and watched Sagan voraciously as a teenager. I only encountered him directly, I think, 3 times. The first was in 1984, in my first term at Cambridge, when he gave an enthralling, terrifying, enraging, rabble-rousing lecture on nuclear winter, the most dramatic of the ways in which he ever applied his thinking about planetary engineering or lack of engineering to the fate and the politics of the Earth. The lethal cooling of the Earth's surface by soot lofted during a nuclear war, he argued, provided a new and compelling reason for deep cuts to American and Soviet nuclear arsenals. When some such cuts took place, he argued that nuclear winter had played a part in that outcome. Scientists had pointed out the reality, politicians had acted. It is a model of political action to which many scientists subscribe. It is not, by and large, how historians account for the end of the Cold War. And it's not a realistic one for reasons that Jessica Seddon put across brilliantly in her talk yesterday for thinking about geoengineering. That said, for a 19-year-old, very hyped up on science and with a whole set of back issues of Omni, that Cambridge lecture, it seems self-evident that if he said it, we should do it. Carl Sagan was saying it. Stephen Hawking was rolling onto the stage to agree with him. So get with the program. This is what we have to do. So one starting point for discussions of nuclear winter came in November 1971, when Mariner 9 became the first spacecraft to orbit another planet. It's close. Oh, come on. There you go. Oh, that should have been up before. There you are. There. Stuff about nuclear winter. Forgot the slide. Sorry. Mariner 9 gets to Mars. Everyone's on the edge of their seat, and it sees nothing because there is a global dust storm. And for most of the people who want to do geology and sort of like look for canals or whatever, this is very, very worrying because they can't see the surface. They don't know how long their spaceship's going to function in orbit. This is terrible. For Carl and for Jim Pollack, who was working with him even back then, and for their grad student, Brian Toon, it's a great opportunity. It's like a natural experiment because there's this stuff in the atmosphere all around the planet reflecting back sunlight, and they have an instrument that can measure the temperature of the surface. And so they do. And they find that as the dust storm abates, the surface warms up. They're seeing climate change. In fact, as Brian Toon puts it really brilliantly, the only global climate change whose cause is known that man has ever scientifically observed. And this absolutely underwrites the value of something that's fundamental to Sagan's thinking about these matters, which is seeing things on other planets allows you to apply them on Earth and vice versa. It's an idea with, as we will see, a sort of like long history going back to the late 19th century. He's a brilliant exponent of that point of view. And it's this experience of seeing a pall all around a planet that comes back in the nuclear winter work about 10 years later. And it's no coincidence that Pollack and Toon are both co-authors on the solar geoengineering paper. So the second time I encountered Carl, close encounters of the Carl kind. The second time I encountered Carl was during the brief, miraculous, incredible few days of another planetary encounter, that of Voyager 2 with Neptune in 1989. You can see Carl in the middle of that scrum. That's Ed Stone, whose head was in back of, who was the PI. And so these few days was the last time a planet in the solar system was seen for the first time in such a way. I saw Sagan, I was a bit tongue-tied. I shook his hand in the cafeteria queue and stuttered something about being honored and influenced, and he was gracious, and he was also very tired. But more delightfully, I was in the cheering crowd when later he took the stage with Chuck Berry to celebrate the end of the planetary section of Voyager 2's mission. Berry was one of the few living artists to have their work included on the Sounds of Earth disc that Carl had caused to be stuck onto the Voyager spacecraft. So Johnny Be Good and Roll Over Beethoven rang out over Pasadena as an era of exploration came to an end, and Carl was up there on the stage twisting away, his arms like happy pistons. The third encounter was indirect, writing a long note to him on a card being circulated at a small gathering of a coterie known as the Mars Underground in the summer of 1996, at a time when he was already very ill. I'm not entirely sure my memory of doing so while sitting on the hood of a large station wagon is correct, but that it was a soft, magical evening just under the frontal range a little outside Boulder is beyond doubt. The Mars Underground was a loose alliance of planetary scientists, artists, writers, technologists, and fellow travelers that came together in the early 1980s to argue for human expansion to Mars, and which saw the eventual terraforming of Mars as a natural endpoint for that sort of presence. As Carl had written the first papers suggesting ways to terraform Mars, writing to him in his time of duress seemed like a natural thing for all of us to do, and I have no clear memory of what I wrote, but I do remember it as being heartfelt, and I have no knowledge that the card ever got to him. Sagan's original idea for the terraforming of Mars, published in 1971, focused on this, which is the North Polar cap of Mars, and kind of gorgeous. Sagan suggested, then as now, Mars's northern summer takes place at aphelion, when the planet is farthest from the Earth. And as some of you will know, Mars has a considerably more eccentric orbit than the Earth does. So aphelion and perihelion make a difference on Mars. And Sagan suggested that when the precession of Mars's axis brought the northern cap to its greatest illumination at perihelion, the sun would be bright enough to cause large-scale sublimation of the gases that are frozen in there. The sublimation would inject certainly water and carbon dioxide and maybe ammonia and methane into the atmosphere, and the increased pressure of the atmosphere would broaden their absorption bands, and the temperature would go up something like 30 or 40 Kelvin. Liquid water would become widespread, and Martian life, dormant during the long precessional winters, would come into its springtime own. Waiting for Mars's precessional cycles to bring this about, though, would mean not studying the phenomenon for millennia, and why not hasten it along? Spread fine powdery carbon black on the polar cap, and it would absorb sunlight, driving sublimation. That would increase the greenhouse effect, and fairly soon, the whole system would be caught in a great big positive feedback loop, with greenhouse gases raising the temperature so that further greenhouse gases are released. It is just conceivable, says Carl, that in time, human endeavors could, by volatilizing the present North Polar cap remnant and taking advantage of the hypothesized instabilities, introduce much more clement conditions on Mars in times considerably shorter than the precessional period. As with a related suggestion for Venus, Sagan 1961, such planetary engineering should be considered seriously only after the most thorough and ecologically responsible investigation of the planet is performed. Those ideas caught the imagination of the young people who went on to form the Mars Underground and eventually spawned a moderately large Martian terraforming literature, which I guess kind of hit its apogee on the cover of Nature It's interesting to notice, incidentally, that pictures of planets that have been changed are a very powerful rhetorical tool in talking about this sort of stuff. Think back to that picture, which I didn't show you for long enough, of the cap of darkness sinking down over the Earth in the nuclear winter stuff. So Sagan's particular ideas about the cap did not necessarily drive these ideas, but the idea of terraforming, of bringing forth a world that he had championed in those ideas, that was very much part of the place. And this is the thinking which, among other things, underlies Elon Musk's notion that a terraformed Mars can, in short order, be made a second independent world for humankind. It's an idea which Sagan, like many of the rest of us, I imagine, would consider at very best terribly premature. As he wrote in 71, such engineering should be considered seriously only after the most thorough and ecologically responsible investigation. Or as he wrote in the 93 paper, if we are concerned that the human species might self-destruct, certainly it makes more sense to devote limited resources to preventing self-destruction than to preparing an escape hatch for the fortunate few. In any case, massive alteration of the environments of other worlds can be done competently and responsibly only when we have a much better understanding of those worlds than is available today. Advocates of planetary engineering should be first advocates of the long-term and exhaustive scientific exploration of other worlds. Now, you'll notice that in that 1971 note, Sagan mentions an earlier foray into the realm of planetary engineering, and that's one aimed at Venus. Find Venus. Venus. And Venus was the subject of Sagan's doctoral work in the late 1950s, and it's kind of impressive that the year after he got his PhD, he was writing a major review paper in Science on the subject. And he begins by noting that in the early 20th century, it had been widely assumed that Venus was a very wet place. As a revered scientist had written in a book called The Destinies of the Stars a couple of generations earlier, the humidity is probably about 6 times the average of that on the Earth, or 3 times that in Congo, where the average temperature is 26 degrees. The atmosphere of Venus holds about as much water vapor at 5 kilometers. We must therefore conclude that everything on Venus is dripping wet. A very great part of the surface of Venus is no doubt covered with swamps. The constantly uniform climatic conditions which exist everywhere result in an entire absence of adaptation to changing exterior conditions. Only low forms of life are therefore represented, mostly no doubt belonging to the vegetable kingdom. And the organisms are nearly of the same kind all over the planet. What this is saying, and in fact explicitly, as we will see, is that Venus is basically the Earth, but 300 million years ago in the Carboniferous. And this idea was translated through into popular culture, eagerly. I mean, it was a way of thinking about another planet as another world. And Venus being a swamp or an ocean was very commonly thought in the 1940s. The one thing where the view slightly falls down is that plants alone are not interesting enough. And if Venus is a prehistoric Earth, it deserves proper prehistoric megafauna like this. Come along, there you go. That's Venus for you. One thing I love about this, comes from 1947, is that scientists agree that the swamps and marshes are filled with huge but harmless monsters. Just how harmless do those monsters look to you? I mean, you know, this is beginning of Firefly monsters. Yeah, this is serious stuff. Anyway, Sagan noted that this theory had a significant problem. More recent spectroscopic studies have shown that there was no water vapor in the atmosphere. Instead, there was lots of carbon dioxide. And radio astronomy had found that Venus shone with a centimeter wavelength radiation consistent with a black body at about 600 K. Sagan was one of the first to argue that this must represent the surface temperature. It could also have represented the ionosphere. And he argued that the temperature was that high because of the greenhouse effect of carbon dioxide and of water vapor created from rain that condensed out of the clouds but evaporated before reaching the surface, thus satisfying the condition that there should be no places where liquid water, silicate rock, and carbon dioxide came into contact, because that would lead to weathering, which would take the carbon dioxide out of the atmosphere. Venus had gone from warm and swampy to autoclave hot. The soggily habitable Venus of the imagination was now a place no human, or for that matter, dinosaur, could imagine living. And the great British science fiction author and editor, Brian Aldiss, marked the transformation with an anthology called Farewell, Fantastic Venus. It featured Edgar Rice Burroughs and Ray Bradbury, and also excerpts from Sagan and Svante Arrhenius. It's a fascinating book. And our picture of Venus, the picture that we put in textbooks, we've no longer give it the shrouding clouds. We actually now show a photo representation of what we take the surface to be like, to somehow communicate its alien planetary nastiness. Having flash broiled the swamps, though, Sagan then, in the same review paper in Science, changes tack. If the environment of Venus is lifeless, can the addition of life make it livable? To earthly eyes, Venus has two problems: too hot and almost entirely lacking in molecular oxygen. To solve these problems, he suggests, we bring in cyanobacteria, nitrogen-fixing cyanobacteria, or as he would have said then, blue-green algae that can photosynthesize the atmosphere away. They will eat up the carbon dioxide, reduce the greenhouse effect, and cool the lower atmosphere. Eventually, things will become cool enough for the rain to reach the surface. The establishment of a liquid phase in the water cycle means water vapor levels begin to fall, reducing the greenhouse effect faster, thus allowing more rain and other positive feedback. At the same time, water, carbon dioxide, and rock start weathering, cooling things further still. And here we see, just in case anyone needs a lesson out of this, here we see an important practical difference between planetary engineering as used for terraforming and as used for geoengineering. Terraformers seek out runaway positive feedback loops, warming on Mars, driving more warming on Mars, cooling on Venus, driving further cooling. Geoengineers are doing their best to avoid them. What I take from these early papers on Venus and a decade later Mars is that Sagan, thinking about how to change planets is a natural part of thinking about planets in the first place. This seems strange to the modern ear, I think. Probably for the last 20 years, it seems strange. That is in part because it is a relic of an earlier way of thinking that I referred to earlier. Sadly for me, and I feel this personally, because I watched the man dance, Carl Sagan now has to be put into a deep historical context. There is a hoary exam question in the history of science: was Copernicus the last of the medievals or the first of the moderns? The answer, or at least the answer I gave when it came up in an exam 40 years ago, and they passed me, is that he was both, but in different contexts. As a practicing astronomer, Copernicus was utterly medieval. In fact, he made no calculations or used any techniques that Ptolemy might not have made. Cosmologically, by putting the sun at the center of the solar system, he was the first of the moderns. So similarly, as a planetary scientist, Carl Sagan is one of the first of the moderns, a researcher whose career starts more or less at the same time as the space age. The reason that the Venus paper is run when it is because the first mission to Venus is about to be launched. And he will be defined in his eyes, in our eyes, on television, by the novelties of seeing planets closely for the first time, and the details thus revealed, an era that is now past. We tend to think of him then as a pioneer looking forward with wonder, collaborating on missions to send spacecraft to Neptune and beyond, sending messages to aliens while he was at it. But as a planetary thinker, he is also the last in another tradition, the tradition of those who first sought to understand whole planets through the tools of science, to fit them into scientific narratives of the ordered cosmos, while startlingly bereft of evidence. Though the essence of the Copernican revolution is normally taken to be the removal of the Earth from the center of the cosmos, its demotion to a planet, among others, has a correlate. If the human world has become a planet, the planets are probably worlds with their own inhabitants. And as science started to conceive the planet Earth as a whole as an object of investigation by physics in the 19th century, it did the same to the other planets, developing theories about their relationship to and differences from the Earth in terms not just of physics and chemistry, but of biology too. And this is the root of the comparative planetology that Sagan carries throughout his life. Indeed, it's the rationale for a whole school of thinking about spaceflight. It's what Robert Goddard the American rocket pioneer, says is the purpose of exploring space, to know the Earth better. Percival Lowell, the American astronomer who is associated with the discovery of Pluto, Lowell said, as a laughing aside in one of his books, no one can consider himself a man of the world who is a man of only one world. So the obvious person to look to in this regard is Svante Arrhenius, who I've just mentioned, the great Swedish chemist. Arrhenius was one of the cosmic scientists who looked at physics and chemistry and biology of planets as a whole in order to understand them. And if people who aren't electrochemists remember Arrhenius today, it's mostly because of his calculations about the greenhouse effect. In order to understand the nature of the ice ages, Arrhenius was the first person to calculate the warming effect of a doubling of carbon dioxide, taking into account the amplifying effect of water vapor in the atmosphere. And it was Arrhenius who cemented into the popular imagination the idea of Venus as a carboniferous swamp. Those are his words about the endless rain that Sagan was quoting at the beginning of his 1961 review. The cosmos Arrhenius thought in and about was one of evolution and thermodynamics, like that of most of the big thinkers of the late 19th and early 20th century. For him, in fact, though it was fairly simple, the two were more or less indistinguishable. Evolution for planets was above all a process of cooling. Venus, hotter than the Earth, was warm and primitive, as the younger Earth had been. As it cooled, it would improve. So I'm quoting now, the temperature at the poles of Venus is probably somewhat lower than the average temperature of the planet. The organisms there should have developed into higher forms than elsewhere, and progress and culture, if we may so express it, will gradually spread from the poles towards the equator. I don't need to add to anyone that this is written at the time, just after the time of peak imperialism, by a Scandinavian looking at the Earth as he sees it. Later, the temperature will sink, the dense clouds and the gloom disperse, and sometime, perhaps not before life on Earth has reverted to its simpler forms or has become extinct, a flora and a fauna will appear similar in kind to those that now delight our human eye, and Venus will then indeed be the heavenly queen of Babylonian fame, not because of her radiant luster alone, but as the dwelling place of the highest beings of the solar system. So there are a few things to note about this vision. Vision one can hear echoes of quite clearly 50 years later in some of Sagan's writing about the sleeping Mars awakening when perihelion sneaks its rosy-fingered dawn across the northern polar cap of Mars. One is that Arrhenius accepts without really any fuss that the cooling of the Earth will eventually lead to the demise of the human race and everything that it holds dear. You know, those are the breaks if you're a planetary thinker. Another is that he does not believe that there are higher beings any further from the sun because the next terrestrial planet out, Mars, has evolved further, cooled further, dried further, and thus devolved into lifelessness. Venus is Earth's past, Mars is Earth's future. And this idea of an older, desiccated Mars leads to the founding image of planetary engineering, that of the canals of Mars. In the late 1880s, Percival Lowell convinced himself and others that it was impossible to see linear features on Mars, which had to be the work of intelligence. He took them to be the last megaditch efforts by Mars's civilization to deal with the planet's desiccation, desertification. As Mars was more evolved than the Earth, so Martians were more evolved than humans, able to collaborate at a global scale in the face of the shifting environment of their planet. People take Lowell to mean, among other things, that communism is actually true and that Mars, the red planet, shows that the workers of the world must unite in order to take command not just of the means of production, but also the means of civilization or survival. Now, other people see it differently. H.G. Wells, a keen reader of Lowell, saw Martian evolution in a more sinister light. More evolution, bigger brains, more technology, no increase in moral stature. The environmental degradation of their native Mars saw the Martians use this evolutionary advantage to invade the wetter, younger, more hospitable Earth, launching the War of the Worlds. Which brings me to my favorite example of this mode of thinking. Hugo Gernsback, another devoted reader of Wells, a Luxembourg American, like my wife's great-great-grandmother, and the man who would coin the term science fiction, imagines the advanced Martians not just moving water around their planet, but also making their own atmosphere in huge factories. And I mean, that's just great, yeah? I mean, those are spinning around, creating atmosphere out using something called Tor energy, which is not explained in detail. And they don't not only make their atmosphere, they also strip the carbon dioxide out of it with huge cubes of glowing purple wire. As the air moves on Mars, he says, as it does on most planets that have an atmosphere, due to the heat of the sun, the air will flow through the wire netting also. Now it is the function of the toss currents in the netting to destroy the carbonic acid gas, and the latter is precipitated in a chemical compound when it falls down in receptacles underneath the wire bottom. It is collected here and used over again for special agricultural requirements. I mean, you know, you could pitch that in the valley today. These atmospheric cleaning plants are erected in sufficient numbers over the face of the planet in such an ingenious manner that all of the air must flow sooner or later through one of the wire cubes there to be purified. Thus does Martian intelligence safeguard the planet's air supply. How long will it be with your coal-burning machinery till the Earth's atmosphere will need its own cleaning plants? I just love that. 1917. That's just great. Other science fiction writers took forward similar ideas, their imaginations fired, as were those of the cosmic scientists, by the idea that all sorts of action on a planetary scale might be made possible by nuclear energy and its attendant technologies, just as interplanetary travel would. As the radiochemist Frederick Soddy wrote in a 1907 book, The Interpretation of Radium, that would greatly influence Wells, among others, a race which could transmute matter would have little need to earn its bread by the sweat of its brow. If we can judge from what our engineers accomplish with their comparatively restricted supplies of energy, such a race could transform a desert continent, thaw the frozen poles, make the whole world one smiling Garden of Eden. Possibly they could explore the outer realms of space, emigrating to more favorable worlds as the superfluous today emigrate to more favorable continents. They could also, of course, destroy the world. As I said, H.G. Wells was a great fan. It was under the influence of the interpretation of radium that he wrote in 1914 the first account of a nuclear war in The World Set Free. I must admit, the nuclear bombs are a little bit more sort of like handheld in back there, but they still, you know, they still do the job. They destroy cities and they force world peace, and yes, all those dreams of the 20th century are there. And the interesting thing is that once 30 years later, nuclear power is actually available in bomb form, plans to thaw the frozen poles and make the whole world one smiling Garden of Eden become the equivalent of nuclear war. You can't tell planetary engineering from nuclear war. This is Julian Huxley, first Secretary General of UNESCO, being reported is talking about blowing up the polar ice cap because, frankly, it's no good and it makes Europe a bit too cold. How many people realize that we could alter the entire climate of the North temperate zones by exploding at most a few hundred atomic bombs at an appropriate height above the polar regions? As a result of the immense heat produced, the floating polar ice sheet would be melted, and it would stay melted. What about the other planets? The great Olaf Stapledon, who's an influence on Sagan himself, on Clarke, on Freeman Dyson, many others, suggested that with superabundant energy, you could get rid of the oceans of Venus through electrolysis, fill up the atmosphere with oxygen. In 1941, a writer called Jack Williamson coined the term terraforming to describe exactly this sort of massive technological brute force reshaping of planets. In 1951, Arthur C. Clarke imagined, perhaps for the first time, that humans, rather than Martians, might improve the red planet's climate through engineering. In this case, the use of nuclear technology to turn the moon Phobos into a second sun. In 1955, Paul Anderson wrote in The Big Rain of the terraformers of Venus reworking their planet's atmosphere with vast nuclear-powered machines for generations until their project reached the crowning millenarian crisis that justified all their effort in a paroxysm of nuclear explosives that releases huge amounts of water from the planet's mantle into its cleaned up air. That would be the big rain. It would last an estimated 10 Earth years, and at the end there would be rivers and lakes and seas on a planet which had never known them, and the soil would be spread, the bacteria and plants and small animal life released. Venus would still be mostly desert, the rains would slacken off but remain heavy for centuries, but men could walk unclothed on this world, and they could piece by piece make the desert green. 100 years after the airmen had finished their work, the reclaimed sections might be close to Earth conditions. In 500 years, all of Venus might be paradise. Yet the irony of this story, which the illustrator captures, is that Venus is not paradise, and it is not going to be paradise because the politics of Venus are not going to allow it to be paradise. It is going to be stuck in perpetual near-nuclear war. Which is where we come back to climate change. Interest in the effect of carbon dioxide on the Earth's climate had lessened after Arrhenius due to a belief that the excessive carbon dioxide in the atmosphere would be mostly mopped up by the oceans. In 1957, Roger Revelle and Hans Suess, incidentally, Roger Revelle's eyes scare me, showed that this was a misunderstanding. Only about a quarter of any given increase in atmospheric carbon dioxide would be offset by the ocean. So atmospheric levels of carbon dioxide must be rising, a trend which had not, at the time, been conclusively demonstrated, and the Earth must be warming. Human beings are now carrying out a large-scale geophysical experiment of a kind that could not have happened in the past, nor be reproduced in the future. Spencer Weir, a historian of physics and climate change, believes that no other sentence in the literature of climate change has ever been quoted more than that one. It was echoed in the speech, and you can read it for yourself, there you go. It was echoed in the speech on the issue of global warming, which Margaret Thatcher gave to the Royal Society in 1988, politically significant as the first discussion of global warming as a policy problem ever made by a head of government. Experiment Earth is also, as it happens, the title of one of the first book-length academic discussions of solar geoengineering, Jack Stilgoe's work of 2015. And I was going to put a picture of Jack Stilgoe next to Margaret Thatcher, but I thought it would upset him. Revelle's image has gained its doomy weight from the idea of being subjected to experimentation without consent and in ignorance. It is entirely reasonable to feel bad about being part of a global experiment. But it is worth noting, as Spencer Weir does, that Revelle did not mean it as a way of sounding the alarm. He certainly did not mean it as a condemnation of the trajectory of industrial civilization. He saw human beings as the conductors of the experiment, not its subject. It was an argument, among other things, for the funds needed to monitor the experiment's progress. Look at the end of the same sentence, of the same part. The experiment, if adequately documented, may yield a far-reaching insight into the processes determining weather and climate. It therefore becomes of prime importance to attempt to determine the way in which carbon dioxide is partitioned between the atmosphere, the oceans, the biosphere, and the lithosphere. This is actually a request for funding. This is saying, International Geophysical Year, let's get with it. We have a great experiment, let's go. And it does actually produce something wonderful, which is it produces the Keeling curve. Roger Revelle funds Dave Keeling's work. Dave then does that curve, which I notice I've used an old version of because it now goes, as you all know, considerably further up to the top right. But there we go. This approach, that of the controller, not the subject, is clearly evident in the first discussions of policy responses to global warming too, which can be found, as a number of you I'm sure know, in a report to on the environment presented to Lyndon Johnson in 1965, in which Revelle had a large hand. This noted this noted that carbon dioxide emissions, which were by that time 10 times larger on an annual basis than they had been for Arrhenius, would in all likelihood start having a major effect on the climate. But there was no discussion in that document of slowing those emissions down. Instead, the suggestion was made that they should be counteracted by deliberate measures to cool the Earth. That is, by what we would now call geoengineering. And this is the world in which young Carl Sagan, saturated in readings of Ray Bradbury and H.G. Wells and Svante Arrhenius and the rest of them, is coming of age as a scientist, a world of the first satellites, of humans moving beyond the Earth, of godlike power, as Stuart Brand will soon afterwards say, a world in which two great scientists, JBS Haldane and Joshua Lederberg, dining together in India in November 1957, look up at a lunar eclipse and wonder if if not all seriousness, at least some seriousness, whether it will be marked by another space spectacular, a nuclear explosion on the lunar surface to commemorate the 60th anniversary of Russia's October Revolution. They do calculations. They talk about it all evening. They watch the moon until it sets, unblemished. But they are not wrong to think that there are such Sputnik-trumping plans afoot. There are, in America. One of the people calculating what such a blast would look like as part of a project that is known as A119 was then graduate student Carl Sagan. You can't think about changing planets, without thinking about changing planets. But I don't want to say that it was just experiments. Experiment was a natural way to think, but there was something more, especially for Sagan, in ideas about planetary engineering. It's a need for life. When Copernicus's 16th century of other planets as worlds becomes accepted in the 17th century, it is assumed that those worlds will be, in Lowell's words, the abodes of life. What would be the point of other planets if they were not? When the other planets are removed from astronomy and brought into the same sort of science as that applied to the Earth by men like Arrhenius and Lowell, they stay inhabited, or formally inhabited. But as science gets stronger, their life slips away. Venus, even before the spacecraft get there, has gone from soggy heaven to baked out hell. Mars is at best hibernating, at worst dead, or even stillborn. And so Sagan looks for ways to fill them, for ways to make the Earth less lonely, just as he turns to radio telescopes to listen for aliens. To think about planets is to think about changing planets, is to think about making planets fit for the life they lack. Worlds need purpose. This can be ours. It's a noble, romantic, and poignant point of view. But it is not one to apply to geoengineering, because geoengineering concerns in all sorts of senses a different world. It is not a change to bring something about. It is a change to avoid things from happening. It is a radical science in the service of something conceptually small c conservative and quite possibly large c politically conservative too. A world changing that at some levels seeks only to stay the same. It is planetary engineering grown from the world of grand planetary ideas, but which has found that it needs politics to temper it, to refuse it, to enable it, to understand it. Part of me dearly wants there to be a Sagan to tell the world that, if the science works out, we can just do this. But even that part of me knows that that can't be how it works. We have to be world and planet both. Without a politics that goes far beyond science says, so do, there is no way for geoengineering to be ruled in or out. And although he did not express it in political terms, that is something which Sagan, I think, understood quite deeply. In 1991, he arranged for Voyager 2's cameras to be used to take a picture of the Earth from further away than the farthest planet. The picture is called Pale Blue Dot because that is what it shows. It is the Copernican decentering of the Earth, perfectly illustrated. The world reduced to a point of light, less than a pixel, almost imperceptible in a cosmos that barely notices it, let alone privileges it, let alone makes it the center, made special only by a seeming spotlight that is in fact just an artifact of shooting the picture too close to the sun. And yet, the world is still the world. As Sagan wrote in what may have become his best known passage, look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you've ever heard of, every human being who ever was lived out their lives, the aggregate of our joy and suffering, thousands of confident religions, ideologies, economic doctrines, every hunter, every forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there on a mote of dust suspended in a sunbeam. The world desperately needs that vision of solidarity, which is why I think it's the most quoted passage from Sagan these days. It needs to be able to see the planet through that refracting, confusing kaleidoscope prism of all of our lives. And by I say all there, I mean, when I say our lives, I mean all life. Just as it needs to be able to look back at a physical dot from the far end of space and think of it as an engineer might. It needs this view if it is ever to forge a politics of geoengineering. It needs it, it may even need it more if it cannot. Thank you. The fact that Doug is standing up with a microphone suggests to me that he's going to suggest that people might ask questions.
Well, certainly people have questions, they should be allowed to ask.
Absolutely.
But I do think they should use the microphone because we do actually have a number of people remote, so. That was absolutely spectacular.
Thank you.
I, of course, as a Cornell faculty, I wish Carl was still here. But
I think we all do. Oh, God, yes.
Questions? Yeah.
So in your book, you talk about the fear of geoengineering coming from the fear of nuclear war, and that are conflated in people's
Mhm.
minds, right? So there's a lot of people in the room who work on geoengineering, and I love, you know, I've also worked on nuclear war, something I don't think we did. So how do we, like a lot of our role as scientists is to try to disentangle that and to get people to think outside of their initial gut reaction, their knee-jerk reaction, which is not unreasonable for my perspective. So I'm wondering if you have any thoughts about us, for us, of how to kind of approach that knee-jerk reaction that people have of technocratic solutions to the climate crisis.
I mean, it is the heart of the question about, because this is not something that can be talked about in terms of, you know, straightforward, popular, progressive or radical politics, I think. And it reminds me of something, I mean, an area that's sort of like, about which there could have been a whole other branch of this talk about defending the Earth against asteroids, about being able to move asteroids in their courses. One of the which is something that I've covered, well, since that Economist cover that I showed you in a moment of gross self congratulation. And I think that one of the issues with that is that people actually found it worrying when this was first being discussed to think that humans might be able to move an asteroid. There was a leader in the Independent in London, I think, suggesting that, you know, maybe it was better not to do that. Maybe that wasn't the sort of people we wanted to be. That's not a view that's now much held. But it's true that the idea, you know, that famous line from much loved by the science fiction writer James Blish from T.S. Eliot, after such knowledge, what forgiveness? How can you use power that operates on a planetary scale in a way that could remotely be good when you don't trust the government to, you know, pick up the trash? I've no idea how you do that. That's what I mean about the difficulty of thinking about a planet as a world and a world as a planet. I think you have to do it as I think this community does, with a sense of humility, with an interest in inclusion. But I'm not sure that's enough. I think you need to find some way to stir up some of that grand spirit without stirring up the sort of like great man theory of history that it tends to lend itself to. And I just don't know how to do that. I really don't. But I'm trying to help.
Oliver, as an Oliver worshiper, that was beautiful. I think your last comment about stirring up some of the spirit without the great man theory maybe answered my question. That's it anyway, which is say more about what you mean about planetary politics, and if you like, say it in terms of some other things other than geoengineering, like nitrogen cycle or the large-scale treaties and agreements now about protecting natural spaces.
Well, yeah, we do. I said we do have something a bit like a planetary politics, but what we don't have, and this is a point that's made in a recent book by Neil Skillman and a colleague of his whose name I disremember, Children of a Modest Star, which is that what we don't have a sense of is what in Europe is called subsidiarity, which is decisions being made at the level that's appropriate to them. And I think there's a fundamental issue there in that individual people cut through levels of subsidiarity. Individual people who are voted for end up being able to do things on global levels, and we don't understand how to partition. No one understands how to partition that power, and that's the real issue. I mean, to some extent, it's that you can't get rid of nation states, and at the same time, you can't really get beyond them. It's one of the reasons, and there are a lot of reasons, one of the reasons why I'm a fairly committed European and why I was destitute at Brexit, is that the European Union has at least made some attempts to move towards that, to say, what should we do as something beyond nations and what should we do as nations? I don't see a politics of that happening on a global level. I'm not sure. I mean, when you look at things like, you know, all the sort of guys I was talking about, people like Julian Huxley or H.G. Wells, they all believe in planetary government, but they also all believe in stuff that borders on the fascist, and they all believe in eugenics, and they all believe that you have to be able to tell people how to live. They want control, and on all sorts of levels of society, and I think it's one of the reasons why it's very important to understand things not control, but the idea that there may be ways to set limits on some activities. I think that's the closest you can get to. And I think that limitation is probably where planetary politics has to exist. But the problem is that as soon as you start talking about limits, you move immediately to, well, let's just limit it. And then you just shut down all the discussion. So I'm sorry that after all the fun stuff about Venus and Mars, I want to work on this problem more. I want to actually take some time away from editing and writing to think about this a bit, but I want to respond to that Gilman book. But I don't know how you do it. I don't know how you create something that's non-state but acts on a planetary level.
Channeling my former postdoc Jenny Stevens, any correlation between these points of views and the fact that everyone you mentioned but Thatcher was male?
No, that's not true. I've mentioned my wife twice. Yeah, no, this was a pretty dead white male sausage fest. I'm quite aware of that. I don't think, but no, I don't. I mean, I think that Thatcher is an interesting example. I think that it's the structure of national sovereignty that is the real issue here. I was going to say the problem, but it's not a problem. It's the way the world is. You know, and so. Yeah, these people and these particular ideas, you could read them as being, you know, like all science fiction since Mary Shelley, according to Brian Aldiss, who I was quoting earlier, is about men not being able to have babies and making up other stories instead. And, you know, Sagan is being mother to planets. But I don't think the fact that the historically contingent fact that all the people that I mentioned were male means that that's necessarily that the problem is one that you can get rid of by having a less male discourse. I think you should have a less male discourse, not for utilitarian reasons like it would produce better results, but just because it's the right thing to do.
Thank you, I really enjoyed that talk.
Thank you.
It seems to me that one of the problems with what you're talking about is that Sagan can be an inspiration equally to those who are against geoengineering as much as they can be an inspiration to those who are supportive of it. And that, I think, in some sense characterizes the whole ambiguity of the situation.
Yeah, I think that's exactly right. Part of what is thrilling about geoengineering is exactly part of what is frightening about it. And, you know, I think that there are people in the audience, one of whom is now on his phone, who actually knew Carl and can speak to this better than I can. But I think that ambiguity was, I mean, that's why I chose to end with the pale blue dot thing. He's intensely aware of the human world around him. He's intensely aware of this strange history that astronomers have of kind of belittling the Earth. They endlessly want to say it's a modest little planet out on the fringes of the galaxy, and yet, well, yeah, it is. But where does that get you? You've got to see it at the center. And actually, another theme that I meant to put into this talk, but thankfully didn't find time to, was the way in which that Copernican view of the Earth being decentered, and something that Sagan writes about in the Pale Blue Dot book, that's been something that we've kind of radically changed by accepting, maybe not in a geological sense, but in common parlance, that the Earth is now a human endeavor, that the Earth is Anthropocene. You can't, and how to reconcile this Copernican idea that the Earth's just this thing of minor importance, with the idea that it's a thing that is intensely created by humans. Very, very, that's why I said early on, you know, I don't know, I know how to make good sentences out of this tension. I don't know how to make good solutions out of this tension. And I think that, and as I say, I mean, I wanted to give a generous reading to Sagan, and this, preparing this talk has actually made me want to go back and read a lot more of him. I think he sees both those things, but his view is very much the view that, you know, you can be a person who's in charge of a planet, and that you would probably do so in a way that a 1980s Democrat, or even that vanished species like the dinosaurs of Venus, the Rockefeller Republican, these are the people that you would see running planets. However, you are able to ask questions to each other rather than me, if that would be more.
Any questions? If not, I'm happy to thank Oliver. That was awesome. Much